Okay, and we're COMP123, and this is week 3, lesson 3, part 1 of the video. And all we're going to be talking today is a couple things. For the first time, we're going to introduce classes and objects, right? So object-oriented programming. This is probably, I would say, one of the most important classes of your coding career, right? Why? Because you're going to learn objects and classes probably for the very first time, at least in C#. If you've never done programming before, this will be your first time around, right? So I'm hoping to describe classes and objects as best as I can. Along that, before we get into what that all means, right, and I'll describe it as best as I can, like I said, let's talk about your first assignment, which is, by the way, up on eCentennial. So you can find the details underneath your the included files that are part of your Dropbox. So go to Dropbox on eCentennial for this course, and you'll see that there's an assignment 1 called the Hero class, which I'll be creating, and it's worth 5% of your final grade, right, for this course. It's due next week, Friday, by midnight, so 11:59. So what do we want you to do? So using my Visual Studio, and you'll understand more when we go through this, and I'll refer back to this over and over again as we go through today and tomorrow, right? What's due. My marking scheme is a little different than you've probably seen before from Professor Narendra, right? He does things a little different than I do. And like I said before, we do kind of things all differently. I take some of the stuff he does, but some of it's going to be my way, my style. So here's what you need to do. When I say maximum mark 35, I mean out of your 5%, I'm taking your 5% and slicing it 35 ways from Sunday, right? So that means like you have tiny little piece parts to that 35% or that 5% to get your 5%, little pieces that I want to mark. So to give you a chance to get full marks, right? So here's what your Hero class is going to look like up here. You've got your the name of the class, which is Hero with a capital H. You'll see why. A few properties. Strength, speed, health, and name, right? For those of you who've ever played any kind of games ever, right? This is not completely unknowing to you, right? Methods. Generate abilities method, very, very simple. A fight method, a hit attempt, a hit damage, and a show method. It's a bunch of methods, but you'll see that they're very, very, very slim and small methods. Even though there's a lot of them, it's how they link together that's important. Okay. Here's an overview. 25 marks for functionality, 6 marks for internal documentation. So I'm asking you to do a little bit of commenting, right? 4 marks for version control with Github. So for those people who've done Github before, we'll talk about that. Who hasn't done Github? All right, well, we're going to talk about that a little bit today and tomorrow, right? So what do you need to do there? Okay. Okay, so the Hero class, what is it? Right? Well, if you notice, it has a bunch of different properties and methods which we're going to describe today. Because when you make a class, just as a precursor to what we're going to be talking about today, you have a certain number of properties or fields, variables that belong to the class, right? And you're going to have methods, right, that are kind of linked to the class, right? Think about your class, when we create a class, as a blueprint, right? Almost like a mini program within our big program, right? So the class itself, whenever we instantiate it, which means when we actually create an object from that class, right, and we'll talk about what that is, I want it to do something. So the first thing I want to do is when you generate the class, the constructor method, which we're going to talk about what that is going to call the generate abilities method, right, which will generate the abilities. And this is, each of the methods here are names. We're going to get back to this, what all these things are. So for me, instead of me going to explain every little piece, each piece that you're going to build with your class, and by the way, this should take you no more than about an hour max for all this stuff, right? If you read carefully. I'm just very detailed about what I'm asking for here, okay? But other than that, don't be afraid of the writing, how much stuff I've written. It just makes it, I'm trying to make it easier for you to break it down, right? So, for example, private properties, strength, which is an integer, speed, an integer, health, which is an integer, it's 3 marks for functionality. So that's your breakdown. So if you do those 3 things, if you forget one, you lose a mark. It's very, very simple. I want you to take my assignments and mark yourself, all right? You should be able to take my assignment, use it as a marking guide, a scheme, and be able to mark your assignment so you can get perfect every time. That's what I want you to do. So my assignments are very, very, very specific. When you see my exams, they're the exact same way. each exam line will tell you what to do, where your points are distributed, how you're going to get your marks. Okay, so there's no guesswork. All right, I'm not going to do arbitrary marking. I'm not going to sit there and go, yeah, this is okay, click. I don't do that. Right? So I look at your code. I actually physically look at it. So that's fine. So what I want you to do is absorb this stuff. It's a lot of information I'm giving you all at once, right? It's there. We're going to get back to it. I'm just showing it to you now. Your assignment's due next week, Friday at midnight. And we'll talk about how to build this thing together. Okay? Let's get right into it. So I'd like you to, the first thing I'd like you to do is, I should probably pass around the attendance sheet because that's important for these kinds of things. All my classes, COMP123. How about I give it to you first? Please initial next to your name. If your name is not on the list, please put your name at the bottom. Okay. I'm going to just minimize this for now, and I'm going to get into, I'm going to start up my Visual Studio. So I'd ask you to do the same. So if you haven't cranked up Visual Studio yet, please join me on Visual Studio right now. I think it's kind of an important piece as we move forward. So I'm going to, with my virtual machine, I'm going to resume it. That's how I run my Visual Studio. For you, just run it in front of you. And one day, when my machine decides to reboot, we'll get there. In the meantime, let's talk about, I'll launch the PowerPoint presentation. And again, I'm not going to go over slide by slide, but I'm going to talk to you about it. The PowerPoint presentation and all the details are up online on myCentennial, eCentennial, however you see it. It's going to be in a PDF format, so you can read it from any reader if you want to. And if you don't want to follow along up here because it's too annoying, right? Because looking up here and looking back, and you want to follow in front of you, then the materials in front of you will be good. These are the same material that comes from your book, right? We talked about before. So it's not anything different. All it does is put your book stuff together into one little PowerPoint. And we're going to follow the PowerPoint as a backdrop to what we're going to do on Visual Studio, just like we did last week. For those of you who weren't here last week, I know there's been a few changes. Bear with me, I do go fast, and we'll have a chance to ask questions. But what I'd like to do is, as I'm going, I'm going to go, right? There's going to be a stopping point when I'm going to ask you for questions, and that's a good time for us to get questions. If we field questions as I go, it'll slow things down for everybody else. If you can't keep up or something doesn't work fine for you, don't worry, I'll come around and make sure it does. Yes, what was your question? How's that? I don't know why the buzzing sound was on in the first place, but who the hell turned on the volume anyway? But okay, so let's get right into it. So we're in lesson 9 right now, and from the book, chapter 9, right? Even though we're lesson 3 here physically, all right? Just so you see how it relates. We may not hit every chapter from the book from here on in. There's going to be some chapters we don't hit, or we might skip or do something else with them, right? And again, I might dwell a little bit on this chapter, chapter 9, for today, tomorrow, and maybe even next week. We got to see how you guys take it and how you understand, because, well, like I said, probably one of the most important chapters in your coding career, right? So let's talk about this a little bit. So these are all of our objectives today. Lots of objectives. Learn about class concepts. We're going to create some simple classes from objects. We're going to create properties and talk about what the difference between public and private is in terms of access modifiers. Learn about the this reference or keyword. We're going to write and use constructors. All that kind of stuff is going to be here. All the things that you need for when you use classes and objects in object-oriented programming. You can ask a question? Can I go back? My back. Oh, it's too big. Is that better? Yeah. Woohoo. Okay, how's that? My bag is too big. So let's talk about this. So there's a couple classes that we normally see, right? One of them is we have an application for C#, and if you notice, there's always a main method, right? But the main method is a static class, yes? Right? Or a static method for the static class that is the main class that runs our application. That's different than what we're talking about here. What we're going to be talking about today is creating your own custom classes, right? So again, in C#, you have to remember that, like what it says, is everything is an object. Classes, your properties, everything really gives you the ability to use methods, method calls, and use access modifiers against it. When we talk objects, when I say the word objects, an object, and I'm going to say the word instantiation, when I say I want to instantiate an object, I want to create an instance, right? So I have a class, and let's think about a class now as a blueprint. So I'm going to use the house analogy. I want to build a house. My house has a kitchen, right? It has some bathrooms, maybe some bedrooms to sleep in, right? It has some walls, right? And a roof. These things are common to all houses, right? So my blueprint for my house has all these things, these properties that I'm talking about. Now the methods are things that, when we talk about methods of a class, methods are things that the class does. So what can a house possibly do? It has to take an action, right? Well, it can provide shelter, right? That's an action that it takes, so to speak, more of an abstract action, right? House can heat. I can heat the house, right? I can cool the house with an air conditioner, right? So those kind of things. So if you think about it, the methods are things that I can do to the house, or I can make the house do my object. Okay, so think about it. It's a blueprint for the house, but I haven't made the house yet. I'm just talking about things that it can do and things that it contains. When I make the house, so I get a construction crew out there and they start building the house, they create an instance of my blueprint. So my blueprint, if you think about it, is just my map, if you will, or my outline of what the house should look like. Hasn't been created yet, right? And that's what a class is. A class is a blueprint of what we're going to be creating. We're going to build something with the class, right? But until we've actually instantiated the object by using the new keyword, and we're going to show you how to do that, nothing's been built. We've just designed the class. We've described the blueprint for what we're going to build, this new object, right? And that's all it is. So when I get my construction crew out there to build my house, we are instantiating or creating an instance of my blueprint. Now, I can use my blueprint a number of times. I can make the same house over and over and over again. And if you look at subdivisions these days, they almost look identical. You might have like 4 or 5 different elevations, and then you're building the same house over and over and over again across the block, right? But that's what we're doing, right? When I say instantiating objects, I'm using different instances, right, of the objects. Each one of them is different. It's not the same house I'm instantiating. They're different houses made from the same blueprint. They have different addresses, 23, 24, 25, 26 on the same street, as an example. I'm just using random street numbers here, right? But so each one of them have their own values for their properties. Maybe they have 4 walls, like I said, and a roof and everything else, but one house might be red and another house might be green. I'm just saying, right? Or one house might have the window on the left side, and the other one house might have the window on the right side. But at the end of the day, they still use them with the same blueprint that I've given them. Right? So each of them can contain their own properties. Okay, so we're talking about the house analogy. Similarly, and we'll just use one more, so you guys get this nicely when we move on. Otherwise, there's going to be some confusion after this. Think about the car analogy. That's another one. There's a bunch of them, by the way, out there. If you go online and try and figure out what object-oriented programming is and what objects are in classes, you're going to see there's lots of analogy of what a class is and how to instantiate them and what they mean by methods and properties. By the way, properties, when I talk properties, they're variables that belong to the class. They're actually contained inside the code block that we define the class, right? So we define the class header, and underneath the class header is this big code block, and inside there we define our properties. Or they're also called, in some sense, you might hear them in other languages, called instance variables, right? They're also called fields. These are the 3 names you're going to hear: fields, properties, instance variables. They all mean the same thing. Okay, there's no difference between one and the other. Okay, so that's the first thing. Methods, again, some places, some programming languages call them functions or class functions. Really, that's what they are. A method is a function that belongs to the class. Because they're part of the class, we call them methods, and we don't call them functions. That's the only difference. Okay? So those are 2 things. Again, properties, they contain values. Methods do something, right? They're actions that we do to the class or we do with the class. Okay. So let's make the car class in our head. And we're going to actually do this physically here when we go to Visual Studio after this. So we're going to make the car class, and a car, right, has what? Has wheels, right? It has four tires, if you will, and it can have a color, right? The cars have colors, right? And a car has usually some doors. Sometimes they're 2 doors, sometimes they're 4 doors. So we can have doors as a property. How many doors does the car have? Sometimes the car has 3 doors, 2 doors and a hatchback, right? But they all have some kind of doors, right? So that's a property that belongs to the car. Cars can do things, right? What can they do? They can drive, right? That's a method. And I can turn left with the car and turn right with the car. Those are two other methods, right? And follow me here, right? Cars can also accelerate, go forward, and stop, or decelerate, right? And they can also go reverse, go forward by accelerating, and decelerate to stop, right? These are all methods that I'm going to make, I can use. When I instantiate the car, so I have my blueprint for my car, these are all the things it can do. We don't know how it's done, right? We don't know how the car moves forward and back, not exactly. We know that there's an engine. We know that the engine, we have to put gas in the gas tank, right? And when we press the accelerator, it goes forward. And when we stop, we push on the brakes, it stops. But we don't know how that stuff happens. Not really, not most of us, unless you're a mechanic, right? And even then, nowadays, you don't know all the inner workings of how the car works. And that's a great example of how classes work. Classes use something called encapsulation. That's going to be a word that you're going to learn, right? That hides all the information in a black box that we don't understand what really happens on the inner workings, right, when we use these classes. Similarly, you're going to be able to do this, right? You're going to have the difference between creating different access modifiers, so to speak, for different properties and methods. Some of them are going to be public, which is going to be available to your entire code. Other properties or methods are going to be private, which is only going to be available to the class itself, right? Before it's inside the blueprint itself, right? And other ones are going to be protected. We're going to be talking about that as we move forward as well. But for now, let's just think about this as we don't know what really goes on when we press the accelerator. We just press the accelerator and the car, and we go forward, right? We turn the wheel, we turn left or right, right? We don't know how it's happening in the back end, but it's happening. But that's how I want you to think about creating classes. When you create classes, the user of the class doesn't need to know the internal magic that you're doing to make it go. All they need to know is use the methods and properties that you make available to them outside of the class. Okay, whew, lots of stuff, lots of little words here, right? So when we get tested, one of the tests you're going to get when we do our first test, a little kind of quiz or whatever, and I'm not sure if it'll be next week or the week after, right? I'm just saying, there's going to be a little quiz. We're going to talk about these little terminology here. And it's important. One of the things is I don't like quizzes, I'll be honest. I don't like tests, period, right? But when it comes to this basic stuff, these basic building blocks, we need to speak the same language, guys. So that's what I'm going to be testing you on. What does instance mean? What do objects mean? What is a class? You know, and we'll have all these multiple choice questions, which, by the way, I'll be sharing with you during the break. I'll do a couple more, right? So if you follow along, you'll get some of these things, trues and falses, and all that kind of stuff that you can use to build up your testing skills. So when you do your multiple choice piece of your test, you're good to go, right? I want to make it as easy and straightforward for you as possible. Okay, any questions at this point? So again, we're talking about blueprints. I've got a class. I haven't shown you how to do that yet. There's some syntax involved. But really, what we're talking about here from object-oriented programming, when we create classes, it doesn't matter whether we're doing C#, C++, Swift, the new language from Apple, C, well, C is not object-oriented, but C++, Objective-C, Python, I can name any object-oriented language. Java, it's all the same, right? Once we create a class, the way we use, if the language is object-oriented, the ideas behind it, the methodology is the same across all classes. That's why this is a very important class. I'm talking about class like in today's session, right? And tomorrow's session. Today's and tomorrow's sessions, probably the two most important sessions you'll have all year. Maybe for a while. Okay, so instance variables, also called fields, right? And then they produce these properties, they're properties for the objects, and they hold data as well. They can hold data for our class. Okay. So when we talk about states, right, for the instance variable, sometimes the instance variable will be initiated, right? Or uninitiated, right? And what I mean is, if I initiate or a variable, I give it a value, right? And sometimes a variable, we start up a class, a variable or an instance variable or property, however you want to call it, could be uninitiated, which means that there's nothing that's in it. It's null starting off, right? What we want to do is if we create properties that's part of a class, at some point or another we should use them, right? It's like saying this: if I create a car, I need to give it a color. Otherwise, there's no color. How can a car have no color? That means you see right through it, right? It's invisible, right? No color. But that doesn't make any sense. So just like making an invisible car in today's technology doesn't make any sense, maybe tomorrow it will be, but today it doesn't make any sense to give a property that has no values at all. So when you have a property in a class, they have to be instantiated. They have to be initiated in some ways. Methods, instant methods. Again, they're associated with objects like we talked about. Okay. Let's move forward. So, what do I want to talk about? Class modifiers. We talked about this already. We said there's a bunch of different access modifiers you can use for methods and properties. Public, protected, internal, and private. The two most common access modifiers are public and private. Protected we're going to use only when we instantiate or create subclasses, which we're not going to get to now. It's probably going to be a lesson or two later from now, right? So don't worry about protected or internal. For now, think about public and private as your two access modifiers. Okay, those are the most important things. And we need to use the keyword class when we instantiate or we create a new blueprint or class for our objects. So here's a class. We've got an employee class here, as in this example. And the employee class has the class keyword. We need to use this. And followed by the name of the class. So this is the identifier for the class. It's not a variable. It's the name that we use, a label that we use for the class itself. Conventions tell us we need to use upper camel case for our class names, which means the first letter of the class needs to be a capital. When I test you, when I give you your assignment, I'm going to be looking for that. And if you notice, it's already there actually. My hero class in your assignment has a capital H, right? So classes by convention have to have a capital for the name, the label that we give them. Inside this code block is where all the magic happens in your class, right? This is where we create our blueprint between these two curly braces. Again, I'm going to use code block as anything that's inside the curly braces, right? And the same thing is these curly braces define the scope for your class, right? So inside this class here, or these curly braces, is not only the code block, but the scope for all your variables, your instance variables, your properties and methods for your class. Again, when we create our class, we need a couple things, right? We define both your attributes or properties. That's another way to say it. Attributes, properties, class variables, instance variables, fields. They're all the same thing, right? Pretty much. And its methods. So here's your field access modifiers, right? Public, protected, internal, private, static. I'm not going to say new. Let's leave that alone for a second. Read-only and volatile. We're probably not going to see a lot of that right now. Again, the most important ones are private and public. The rest we'll talk about after, right? Most class fields are non-static, right, and private. What does static mean? Do you guys remember what it means when you make static? Correct. So imagine if I make a car, right? I don't know how this would be. I make a blueprint for the car, but I can actually drive the blueprint. That's impossible, right, in real life? It's really an abstract way of thinking, but that's what static variables do. It's almost like we never have to actually build the car to drive the car, right? So sometimes we use static classes to hold data. So in other words, we actually don't need to instantiate the class. Like for example, our main method or our main class we run our program. We never really have to instantiate that class our program is contained within. So therefore, it's a static class. We can use its properties and methods, but we never really have to create a new object from that class, right? Think about it as, again, a container. I would use it more, when you see static classes and methods, they're more container objects than anything else, okay? So there's nothing that we're going to need to instantiate. We just need to store some data in there, right? That's why we use static objects and classes. So again, we've got this example of class employee, right? Employee class with, you know what? We have a private access modifier here, right? It's an integer, and it's the employee number or the ID number for the employee. This is a property, right, that belongs to the employee class. Can I access this property right now? No, I can't access this property right now until I instantiate, until I build this class, right? The class is just a blueprint. Until I use the new keyword and instantiate a new object from it, breathe life into the class, right? This is just a design. That's all it is, right? So I can't use this stuff in here right now. All I'm doing is designing what it's going to look like, the blueprint for what my objects are going to look like. All right? Let's continue. I talked about information hiding when I talked about the car analogy, right? I'm driving the car. I'm here in the car. I'm driving left. Ooh, I'm driving right. Ha, ha, ha. I don't know what's making me drive right and left. Do you guys know about axles and about, you know, how it works and proportions and the speed, the rate of speed of your wheels compared to the gearbox? You don't know these things, right? So because of that, we don't care about these things really. We buy a car, we wouldn't just drive it, right? So that's information hiding in a nutshell. If you think about what information hiding means is keeping the stuff inside your methods, the ability for me to turn left and turn right, private. I don't want to know anything about it. I want to be able to use it, right? But the internal workings of my car got to stay so I don't know about it, because maybe my brain will explode, right? If I know everything about the car, I might get worried, right? Maybe who knows, right? If I'm driving a car, and especially if I know statistics about how often they fail and stuff like that, maybe it'll bug me. Maybe I'll get into an accident. But that's not the real reason. We don't need to know these things. Just like when you fly a plane. The pilot of the plane doesn't know how the engine works 100%. He knows that if he pulls back on the rudder or the stick, it's going to go up. If he's going to press forward, it's going to go down. Turn left, it's going to turn left, and turn right, it's going to turn right. And he's got a bunch of switches for other things. But in fact, he doesn't know exactly how the plane operates. Most people don't. Unless you're a scientist or an engineer, you don't know how things work exactly. We're the software engineers that make software, so we're going to know how they work inside. But our users, the people who use our classes and objects, they're not going to know. They're just going to use our stuff. So when we make a library of objects and classes, right, we're going to use information hiding by using different access modifiers, right? So that way some things are going to be visible to the users through code hinting when we use Visual Studio, right? And other things are going to be private. They're not going to even be visible, right? And we'll see how that works in a bit. So again, like we said here, most class methods are public. Yes and no. Private data or public method arrangement. Again, what we can do is we want to keep our data private, right? It's how we keep our information. Like an example in the hero class for your assignment. I want his strength and his speed, or her strength and her speed, if you're making a female heroine, right? We don't need to know exactly what it is until I actually to show the hero's abilities. Those are private, right? And we'll talk about that. I don't want those things to be public unless I access them, right, through some kind of method, right? So private data, public methods is the best way to do stuff. And there are going to be some methods that are private as well, internal methods that we use, utility methods, so to speak, to make do of something. Like, for example, maybe I have a method inside of a class to do some kind of random number generation. I don't need to make that public. That can be something that the class uses to generate the number. Almost like, think about a class as, like I said, a little program of its own. It's going to run stuff in the background in this black box idea, right? And it's only going to show the stuff that we need to show. Let's move on. So here's an example of our class, right? So we've got, and I'm sorry for the people on this side of the room. I'm standing on this side. I apologize. Again, you can look at the PowerPoint in front of you. The important thing is here, we've got a class that's employee. I've got a couple of things here. I've got one, which is my private property, right? Here's a private integer with an ID number. And I've got this method, right? I've got a public method. Here's my return type for the method, just like we've seen methods many, many times up till now, right? Same idea. Here's my public method with a void return type. It's called welcome message. Now, I'm not 100% really happy with the fact that it uses a capital W here. My methods use camel case, okay, all my methods, and that's what I expect from you, right? Upper camel case for class names, camel case for properties and methods. And as you see, most methods are like that, right, in most languages. Now, if someone was to quiz you and say, I'm not going to put a question on the exam or anything like that that's going to say, well, what do you use for, I'm not going to do that. So don't worry about it. I'm just telling you from a convention perspective, when I do programming, this is how I do it. You might have your own way. Just make sure it's the same every single time, right? Don't capitalize some things and use lowercase in some things. Use underscores somewhere, and don't do that. Keep it, consecutive or the same way all the time, right? Okay, so here's a couple of console.write lines where we give some messages, and we're using some string interpolation here by taking the ID number and putting it inside the string, literal, and we're printing it out. We're showing what it is, right? So it's going to say, here's my welcome message. This welcome message, I'm going to ask you again. If I instantiate this class, will it run? No, I haven't called it. I haven't called this message. I'm just defining it here. I'm just creating a blueprint for my methods. Here's my blueprint. Here's my blueprint for my ID, my blueprint for my method. I haven't used my method though, right? The method isn't used until we call the method, just like every other method. Right now, all we're doing is defining them inside the class itself, okay? So this is a good thing, exactly what I said. The class, declaring the class doesn't actually do anything. It doesn't instantiate or create any method, objects. So there's two steps to do it. One, we got to supply a type. So the type itself is the class name. That's the type. I'm creating actually a new data type, if you will, right? When I create a new class, right, I'm creating my own custom data type. And then I create the object which allocates memory for it. So I say, well, take my data type that I've just created, just like I use string or int or float or whatever, and I want to put aside some memory for this class, this object, right? And when I instantiate this object, properties and methods run on its own. So I can have many, many objects based on the same class. For example, I can make many, many cars. Different makes, different models. A make and a model might be properties. Colors might be another property, right? Maybe it also has a speed property, which is a different kind of property. It's a data holding property, right? So I'm not going to talk about reference types for a second, but the most important word is this. Constructor, which we haven't seen yet, right? So what is the constructor anyway? We'll talk about that in a second. Here's an example. I've got my, I'm using system, which means I'm importing the system. Here's my class, create employee, and if you notice this create employee program, it's using the static void main because what I'm doing is this is my main program, and it's a static class. I don't have to instantiate this thing, right? But look what I'm doing here. I'm taking my custom employee class, and I'm using it just like I would any other data type. This is how I would declare it. So here's my custom class. This is my new variable or object, if you will, right? I need to use the new keyword, which is important, right? And I need to kind of use my class. What am I newing? What am I creating? I'm creating a new employee, right? And if you notice, I use closed brackets or closed parentheses here with nothing inside because I'm not passing anything to the constructor. We haven't talked constructor yet, but follow me here. And here, I'm using the dot accessor methodology, right? Dot notation to access the method, just like we do with built-in methods, right, of part of C#. So here's my new object that I just made. I breathed life to it by using the new keyword, right? And now, after I've breathed life into it, right, I'm accessing this new public method, right? Let me go back a couple. This public method called welcome message, I'm accessing it, and I can't see it. I can see it because it's public, right? And I can see it inside my program. This is my whole program called create employee, right? I can see it, and I can access my method. Okay, let's take a pause. Do you understand? Who does not understand? Who is like out to lunch? They're looking at going, what the hell is he talking about? He's talking Greek to me. Like half. Right? You're half. Okay. Some people may think this is totally whacked, right? They look at it and they go, this is not right. What is he saying, right? Well, we have to do it for you to understand. Let me take it a little further, and once we talk constructor, then we'll go and do it, okay? Okay, so again, we're accessing the class through the program, right? Our program is called create employee, just like we normally have a program. I'm not going to do this. Okay. So here's our program, right, again. And our program has, by the way, our class employee isn't here. Our class employee is in another file for now. Okay, think about this. We're not defining our class here. We're accessing our class here, just like we would a data type, right? So here's an example. I've got a couple of employees. I got a worker. I got another worker, right? There's two different employees using the same class. All I'm using is the new keyword to breathe life into two different objects, a worker and another worker, right? So they both use the same class blueprint called employee. They're both employees. Once we instantiate them, they become those employees. They're not the blueprint anymore. They're actually physical things, if you think about it. We take from the abstract, which is the blueprint, almost like a pie in the sky thinking kind of thing, and then all of a sudden, poof, they're created, right? And now we're going to display employee data. Here's our first, right? A worker. If I do this, I'm going to get information about what the A worker is. A worker is actually an object of the employee class. And so is another worker. Both of them are different objects of the employee class. When I breathe life into them, just like human beings, if human beings had a class, right? We have eyes, we have a head, we have two arms, two legs, we have some internal organs, we have blood, all these different things. We're all human beings. We belong to the human being class, but we're all individuals. So too are these two employees, right? Even though they're made from the same class, right? We're using the new keyword to breathe life into them using this blueprint called employee. They're different employees. They're not the same employee. They don't share anything. They have their own memory locations for their properties and their methods. Okay? Whew. I know it's on the order of insanity until you actually do it. But bear with me a little longer. Okay. Actually, let's do a little bit now. I don't want to go into this much more without doing stuff. And we won't create a constructor for the class. We'll just do what we're doing here, what we see up on the board. Okay? Except instead of making an employee, I want to make a car class. Okay, so let's do this. Let's switch into Visual Studio, right? I know I've talked for a bit. I want to do this, and we'll take a short break, and then we'll continue. Okay, so let's go into my Visual Studio here. And what I'm going to do for the first time, I'm just going to close this stuff down here. I've got my Visual Studio open. I'm going to save this and close it up. And I'm going to close my solution. I want to sign up for GitHub really quickly. Let's just take a bit of a break here. I'm going to go to GitHub. Who's not signed up for GitHub? If you haven't signed up, it's okay. It doesn't take much. What I want you to do is I want you to go to GitHub, right? We won't do anything with GitHub today, right? We're going to do with GitHub something tomorrow, but I want you to sign up today, right? I want you to follow along, but not necessarily do what I'm doing. Not yet. So in GitHub, when you sign up, by the way, I'm just going to go there as an incognito visitor. Woohoo! Incognito. I'm going to go to GitHub. Oh, let's try that again. GitHub. And when I go to GitHub, you're going to see this, right? When you see this, you can sign up. It's a free account, right? And when you do so, you can't create any private repositories. They're only public repositories. And think about repositories as a place to keep your stuff, right? Almost like a folder that's online for now, okay? So like Dropbox, like not Ecentennial Dropbox, I'm talking about Dropbox, right? Or Google Docs, or someplace like that. GitHub provides a place to keep your code. But further than that, it allows me to keep all my repositories up here. So if I click on myself, I've got a series of repositories that are in here, right? That you can follow me on. For example, we've done this before where I've gone up to GitHub and I've shown you how to connect. And you can find me at GitHub. You can go to my repository, or if you want to go to github.com/my last name, Sodiopoulos, right? You'll find me. You can actually see my repositories here, right? And these are all the repositories that I have that are shareable that you guys can all access. Okay, so please, for today, create a GitHub account, right? I'm going to create a little mini assignment today, and I've done this in other classes, where I'm going to get you guys today, for 1% of your mark, because as you've attended, I want you to create and sign up to GitHub. If you've already signed up, I'm going to create a little Dropbox over the break, right, on eCentennial, where you can someone let her in? Sorry. Where you can hand in a link to your GitHub account. That's what I want you to do for 1% of your final mark. So 5% you're getting for your big assignment that's coming next week. 1% I'm going to give you right now, right, today, for signing up to GitHub for the very first time, right? This is a pretty good deal for you to sign up. And I didn't do that day one because it wasn't so important day one. I did it today because I wanted you to get into things, right? And if you've done this, I'll do this every single one of my classes. If you haven't signed up, I want you to send me your GitHub account information. So it'll be github.com / and whatever your username is going to be in a little text file. That's what I want you to send to me. And I'm going to set that up during the break, which we're going to take in about 10 minutes or so. In the meantime, I'm going to create a new repository. I'm going to go new repository. And inside there, I want to do a new one for today, COMP123 - lesson 3. Okay, I'm going to create a new repository. You don't have to do this with me. I'm just showing you what I have to do. In here, I'm going to create a new project, and it's going to be a C# project. This you may want to do with me. I'm going to do a new console application. I'm also going to add it to my Git repository, which you do not have to do, right? You can leave this source control stuff unchecked. Here, I'm going to create a new repository that I'm going to name COMP123 and lesson 3. And it's going to go inside of my GitHub repository where I keep all my repos, a bunch of different ones. Okay? I'm going to press OK now. When I press OK, Visual Studio creates my base project, right? And if you notice, I have my namespace, COMP123 lesson 3, and a bunch of other things here that I don't need, like for example, collections generic, system link, system text, all that stuff. I don't really need it. I'm going to leave it there for today. Last time I erased it, or I removed it. Today I'm not going to. I also have a class called program, right? Class called program, and we talked about how to refactor that a little bit last time and change the name of that class, right? But my namespace, COMP123 lesson 3, remains. Okay? I'm going to keep the namespace the same and keep the class program the same so we know that it's a program that we're creating for today. All right? But we're also going to create a new class. Right? So how do we create new classes? Well, we kind of did this before. But let's do it again. Right? Right-click on the projects. I'm going to go to Add. Right? I'm going to go to New Item. Right? And when I go to New Item, it's going to say Class at the top. Right? Let's do that again before I do that. I'm not going to add it in yet. So again, I'm looking at the Solution Explorer on the right-hand side here. Right? I'm going to go to not to the solution itself, but to the project, which is COMP123 lesson 3. I'm going to right-click onto the project. I'm going to go to Add, right, in my context menu, and New Item, which is you can also get through Control-Shift-A. When I do that, it's going to come up with this dialog box, and on the top, I want to hit Class. And down on the bottom, I want to rename this class, and let's call it Car with a capital C. We're making our car class. Right? And press Add. Leave the CS alone. Don't change it. So it's going to be car.cs. Okay? So now I have two classes. I have my program class, right? And I have my car class. When I look at my car class, look what it has. The same import statements, the using statements, right? The same namespace because it's inside of my COMP123 lesson 3 folder, although I could change this, right? And then my class declaration code block. which is these 2 points right here, this struct, right? So I've got this curly brace here and my closing curly brace there. Inside my car class, though, there's nothing. I can put as much white space as I want right now, and it doesn't do anything, okay? Now I can do a couple things. We know that cars have a couple of properties. Let's talk about those properties, right? I know I have a make, so let's put that in there, make. And now what type of, remember when we declare a variable, right? Do I put it before or after? Well, I put it before. So I've got to declare what type of variable make is, just like as normal. Make should be probably a string, because it could be like, you know, different kinds. So let's put string in there, right? And it's going to be called make, right? I don't have to instantiate this variable right now, this instance variable, because we don't know what make it is, right? And the other thing that a car has is a model, which is probably also a string, right? It's also has its own color. We're going to use the Canadian spelling for color, right? Not the American spelling, American. And so make, model, and color. And what other things does it have? We also have some data that this car, you know, keeps. For example, we keep track of the car's speed. So let's use it as an integer, right? We can make it a float, but for now, let's make it an integer. Yes? When you go to new item? Did you instantiate the right C# project? I'll come around after the break, okay? Or during the break. Okay, so string make, string model, string color, int speed, right? And let's initialize this speed to 0, right? So we've got some that are uninitialized, and we have some that are initialized, right? Hey, let's have a question here. Should the make, model, color, and speed be all public variables or public properties of my car class? Speed, well, sometimes we might get speed reported to us, right? Through like an through a speedometer, right? We don't have a speedometer method right now, right? But for now, let's leave them all as public. Just bear with me, because each of these methods, right, as an example, we can make them as public. We can always change them to private in a second. Okay, so we got a bunch of different make, model, color. Right now, the car doesn't do anything, right? It just has a bunch of properties, right? Okay, how about we create a method, right? And we need to declare what kind of method it is. So it's going to be a public kind of method, right? It's going to return void. Public void. It's not going to return anything. And we're going to call this thing, you know, drive, right? Or maybe, yeah, the drive method. Okay, we're going to use, it's not going to take any variables or parameters right now. And what we're going to do is we're going to use code block. And when we're going to say console dot write line, and the car is driving, right? It's not even the complete sentence. It's not driving, it's driving, right? Because that's the way I am. Yes, what was the question?
The drive calculator.
Is it what?
The drive is calculator.
It's a method, so it's not capitalized, right? It'll be camel case. If I say drive now, or some kind of multiple word like drives forward, here, let's change this just for you. I'm going to change the methods. Everyone else is going to change because of you, right? Drives forward, right? Is it's camel case, right? Which is the same thing as drives. Similarly, I can have the car is driving forward now because of our friend, right? Right? It's a public, that's a public method that we're going to use, right? And you know what? When we're driving forward, we're also going to set our speed, right? If I say speed, right, is equal to 10, is that allowable? Well, apparently it is, but what speed are we talking about? We're talking about this speed, right? We're also going to see that that's not the right way to do it. but let's leave it for now, just to play, right? Speed is equal to 10, okay? And what I want to do is I want to say, maybe on the bottom, I'm going to say console dot writeLine. I'll say speed, right? And I'll do some interpolation here. Oops. And comma speed. Is that allowable? Okay, so that's all I've got right now. I don't have a constructor. And here's the question for people that are done object-oriented programming before, maybe some of you. Do I need a constructor in an object in a class? Do I need it? And the answer is no. I don't need it, but it's almost automatically, there's automatically an empty constructor that's, if I don't instantiate or if I don't create a constructor, then C#, when it compiles, automatically adds a constructor. And we'll talk about what that constructor is. Okay, so this is good. I've got this now. And I've got my class. I'm going to save it. And I'm going to go back to my program class. Here's my program, my main program. And now, for the first time ever, I'm going to instantiate a new object of that class. So here's what we're going to do. We're going to go, we're going to go in between the curly braces as normal, and we're going to say, well, we know car is a class. And look, you should be able to get this code hinting right here once I type car. Because you know what? I'm using the same namespace. If you don't see this car object, right? If you don't see the car object, then you haven't done something right. Right? The car object should be available to you because you know what? I've created it within the same namespace. Right? So I'm going to say car, and I'm going to call this, we're going to call the class, I don't know, the actual name of the class Honda, because we just, we drive Honda cars. Come on. Right? Well, that's equal to a new car, right? That's what the Honda is. It's a car. It's a type of car, right? I could also, instead of calling it Honda, because Honda is really like a make, right? I could also call it my car, which is more common. You might see my car is equal to new car, right? But at the end of the day, we're still creating its own class. Okay, so here's my car. And now, with my car, I want to use the method that's attached to my car, and I'm going to use the dot notation method that we use. I'm going to say my car, and if I press dot, I get all these different methods. And look what I also have. I also have access to the make, the model, the speed, the color, right? I have all these things. I also have the drives forward method that we made together, right? So let's use this drives forward method, right? So I'm going to double click on this drives forward. And if I open my braces, it tells me this is what it does, right? And I can press save. I got a bit of a problem, don't I? It's going to flash open and close, right? So in our inside of our static class here, static void main class, our method, I want to do a console dot writeLine, and I'll say press any key to exit, because otherwise we're not going to see our console, right? And I also want to do a console dot read key. Right? I need to do that because otherwise it's going to go whoa and goodbye, right? So we can't have that. Now if you notice these instructions I've given my program, these instructions here, I'm doing them in the main method of my program, right? But I've called upon a class that exists in another file which is part of the same namespace or part of the same project that I'm using. That's all I'm doing. Let's run this thing to see if it works. And then we'll take a short break. Okay, if I run it, it says this car is driving forward. It says speed is 10, press any key to exit. And I've got some warnings down here, right, that come up. Let's take a look at some of these warnings. You should have the same warnings that I do. It says field COMP123 less than 10, car make is never assigned to and will always have its default value null. And I also have some other warnings here because I've never used these fields, right? I've got a bunch of fields that I've never assigned anything, never initialized, right, to anything. And that's why it's giving me these warnings. But otherwise, we're good to go. So questions as to what we did here. Let me run that again one more time. So again, I ran it, and if you notice, use the car is driving forward because I called the my car drives forward method, right? And of course, when my car drives forward, my speed changes to 10, right? Because inside my, I'm going to go to my car class, drives forward method, I set my speed to 10. That speed, by the way, is the speed of my car, right? Now, right now, it looks all the same. And I haven't used make, model, and color. And right now, every property is public. And let me do that again. Let me see if I start instantiating a new object, right? So if I go back, I'm going to go under here for now, just to do a test. It's not really going to be true. I'm using like a playground, okay? And if I go car as my data type, that's my new object that I've defined, or my new class that and I say car2, I'm going to name a new car, is equal to new car, right? And if I start typing car2 dot, I get access to my color, my drives forward, some other stuff I didn't define, right? I didn't define equals or get hash code or get type or toString. I never defined that stuff. How come I'm getting it? Who knows why? I'm getting other methods and stuff that I never got from anywhere else. Oh, you're a smart girl. The answer is because even though I'm creating a new class, all objects in C# inherit their properties and methods from the super class object that exists when we start compiling C#. There's something that exists called the super object, the object class, and everything else comes from it. Now we don't see that; it's just part of C#. So all classes inherit from that class. And that's why we see these other classes and methods, or these properties and methods down here. But the ones we want to not see is make, model, and speed. I shouldn't be able to see those things when I instantiate my car. I should use methods to instantiate those things, or to create the value for those things, like my make, model, and speed. And some of that should be done in the constructor. So I should be able to pass in, hey, I want to make a car. Well, my car is a Honda, right? And my car is a Honda Pilot, right? That's a different model, Honda Pilot, right? And you know what? My speed, my initial speed, I should be able to set that up too, maybe, right? Or something like that. Or maybe I should have a set speed method that sets my speed when I drive. So right now my speed is 10, but maybe what we need is a set speed method. A set speed method that's also public for now. Let's write that. Void set speed, right? And what am I setting the speed of? Well, I'm setting the speed of my speed variable, right? But I'm going to pass in this time, just like in any other method, I'm going to pass into this an integer, which is called new speed. Here's my new speed integer, right? And I'm going to say speed is equal to new speed. Sorry, I know I'm kind of, that's a new method I just made, right? So I've got two methods. I got a drives forward method. And by the way, what does this thing do? Well, it causes the car object to drive forward, right? And this one causes the car object to change its speed, right? Here we have all of our public methods, public properties, or instance variables, if you will. I'm going to just use some fancy characters here to do that. Here's some public properties, right? And down here, right, I'm going to separate this section, and I'm going to call this public methods, right? Why am I doing this? So it makes it easy for me to break up my code a little bit with some separators like this, right? And if you notice here on the right, inside of my my scroll bar, I can see that there's a big line here and a line here, right? Like right off the top. See, there's a line right here and there's another line over here. So I can tell that this is the top of this piece and this is the separator for this piece. I have a little underscore here a little curly line, a little red line that's basically saying that I have a spelling error because drive-in should be driving, right? But I'm gonna ignore all these instances of the drive-in from my thing. I'm gonna save my new class, is my car class, right? And when I go back to my program, I'm gonna go to car2, right? Let's go back and press the dot again. And if you notice now, not only do I have drive forward, but I also have this other thing that has set speed. Here's my set speed method right here, right? Set speed, right? Now I created my own set speed method. You're going to see later on we have setters and getters we can use. We'll identify what those are. But for now, if you notice, my set speed method is available to me now because I made it public. I created a new method that's part of this new data type, this new object that I created called car2. And I'm going to be able to set the speed of this car, set speed. And if you notice, the code hinting tells me, I'm going to kind of go on this side now, the code hinting tells me that I need an integer, right, that I need to pass into this constructor, right, or into this method. And my integer can be any integer I want. I can't pass in a float. It's going to error out. I can't pass in something else. I must pass in an integer, even if it's 0. So 0 is acceptable, and then it won't error anymore. Well, if we can do this set speed outside of the class, this is doable. I'm not gonna run the program yet because I'm just using this to show you what's available to me through code hinting. Only public methods and public properties will be available to me through code hinting, right? If I make these things private, these options will go away. Okay? So then, if I go back to my car example and I have my set speed method, could I not use it here? I am setting the speed to 10, right? Could I not just say set speed, I can, you notice it comes up to 10. What does this do? One method drives forward, calls another method, set speed, and I can set the value for my speed over here, which is public. Well, if I can do that, do I really need to make my speed public? Probably not. So now let's change our speed to private. Right? So now this is public properties. I got to make another little division. Here's my private properties. Right? Here's my private properties. So public properties, private properties, public methods. I don't have any private methods, but this is how I'm breaking it up right now. Right? Okay, cool. Let me go back to my program. This is just an example, right? But let's see, can I access my set speed property anymore? Well, somehow I can't, right? How come? Well, because my set speed property is public. But how about my speed method, my speed property? It's not there anymore, right? See how it's disappeared? My set speed method is public, so I can access it. But my speed property, like color, make, and model, if you notice these little blue dots here, I know it's kind of hard to see. Let's see if I can space it upwards a little bit for you, right? So it's above my head. So if I press dot, and if I say this little blue icon here, right? It's color, make, and model. You can tell these are public properties that are available outside of my class. But I don't see speed anymore because I made it private. And these little squares, like we talked about before, they're methods that are available, public methods that are available for my class. Right? Now, there's a couple methods we don't know what they are, but drives forward and set speed are available. One more thing before we go on. Let's just get rid of this because we don't need this anymore, right? Let's test the fact that we can use our internal method called set speed, right? And then the question should be, should we be able to set the speed of my car directly? And probably the answer to that is no, right? We should have to press another method. For example, when I drive forward, I set the speed positively, right? And when I drive backwards, I set the speed negatively, right? But I shouldn't be able to set the speed, like there is no car that you can press a button and all of a sudden go 10 kilometers, right? It doesn't work. And that's what I'm doing. I'm pressing the button and all of a sudden I'm going 10. That's not right. I should be able to increment my speed or increase my speed over time. right? As long as I press my drives forward button or my accelerator, right? As long as I drive forward, I should set the speed at a certain rate. Drives forward is even a bad name. It should actually be accelerate. That should be the right method that we should use. Accelerate forward, right? And so on. But for now, let's leave that as the way we've written it, just so we understand. It's for understanding only. It's not for realism, right? Again, drives forward. If I make my set speed property private, right, it will still work within my class, right? Here's my, now I've got private methods, right? My only one right now is this set speed method, which is private. I can still access it here, right? Because it's within my class. However, when I go outside of my class to the program and I want to do one of these, my car, and I say dot, I don't have a set speed method because it disappeared, right? I made it private, and so therefore I'm hiding it. It's not available to me in my code hinting, and even if I type it, because I know it's there, and I do this, it's going to give me an error, right? It's going to say void car set speed, right? It says error, right? It's inaccessible due to its protection level. Even though it knows, Visual Studio C# knows, the C# compiler knows that it's there, right? It even gives me a signature. Here's my signature for it, right? This is my signature for the method. It tells me my signature, but it also tells me that it's private. It says I can't access these things because of protection level, just like it would normally do with any other method. So I can't use it. Even if I tried to compile this right now, if I said start, right, it would say, hey, there's build errors. It won't even build because this method is private. Okay, so let's take this away. And if I run it now, before we stop for a break, which is overdue for some of us, right? And then we'll get the same thing. Speed is 10. I've got a few of the same warnings. But this time, when we ran it, when we go to the car object, this is a private method that was run inside of a public method. My public method, which is exposed to the universe, right, which is drives forward, calls upon a private method called setSpeed. Okay, let's take a break there, and I'll field some questions.